And on we continue with our polynomial work and some synthetic division. Let's just kick things off with a just a little recap question. So perhaps you could copy down this question and then pause the video and attempt it. It's gonna be a biggie so that we get plenty of practice. We can get into the swing of it again. So we'd like to find let's calculate 2x to the power of 6 minus 4x to the power of 5 minus 5x cubed plus 2x squared plus 3x minus 1, and we're going to divide this guy by x minus 2. So find the quotient and remainder upon that division. Okay, so go for it, pause, and then come back. Okay, so let's carry out this division. Actually, it's an upside down division, isn't it? Upside down, where we have our 0 here. Remember, our 0 is all important, and our 0 is 2. So 2's what we divide by, and then we plug in just the coefficients, not missing any, and also not missing negative signs. Right, Sherwin? 2, negative 4, negative 5. 2, 3, and negative 1. I don't think I've got any powers missing. 3, I'm missing 4. Look at that. So I'm missing power 4. So after negative 4, I need to put a 0 in because that's my power 6, power 5, power 4, power 3, power 2, power 1. And there, I just need to extend my line out a little bit here and put another line down as well. Okay, power 6, power 5, power 4, power 3, power 2, power 1, all my negatives in place. Hopefully we're okay. 2 just drops down, and now we multiply and add. Multiply first, 2 2's are 4, add, 0. Multiply, add, multiply, add. Multiply, add, multiply, add, multiply. I just went and did the add before I multiplied. Negative 27. So this would appear to be so my px. My px looks like this to me, that I've got x minus 2 as the divisor, and my quotient turns into this guy here, because I've divided by a linear. That guy is now power 5, so 2x to the power of 5, 0x to the power of 4, 0x to the power of 3. How'd I go there? 6, 5, 4, no, minus 5x to the power of 3, minus 8x squared, minus 13x. I've made a mistake in here. It's probably better, actually, given that I'm working in this fashion, to write just underneath that x to the 5, x to the 4, x to the 3, x to the 2, x to the 0. That's just my constant, and that's my remainder. Okay, so if I'm going to get this right this time, I will have my divisor here. I'll have 2x to the power of 5, and then I go minus 5x squared, minus 8x, minus 13, and my remainder is negative 27. Okay, I've got another example for you. Okay, so I hope you're impressed with the speed of this synthetic division, and perhaps you're converted to using it. Although both methods, long and synthetic, are expected as part of the course. So we do need to know both methods, remembering that synthetic division just works for linear division, linear divisors. And we have another one here in an example, but it's slightly different in that the leading coefficient is not a monic. It's not a monic linear. Monic refers to the coefficient of the leading term. When it's 1, it's called a monic polynomial. So this is not non-monic. We're dividing by 2x minus 1, but so we've got to divide by. We're going to do our upside down division. We're going to use synthetic, right? I'm going to see what we. Well, let's do both actually. Let's do the long division as well. Let's go over here and do long. I'll just go. So long division will look like this, and I'll go 2x minus 1 into 8x squared plus 10x minus 7. So perhaps pause the video and do this one for practice. Okay, 2x into 8x squared goes 4x, and 8x squared minus 4x down here. 14x, once you subtract that negative, bring the 7 down, and we've got plus 7, 14x minus 7. So this looks like 2x minus 1 is a factor. So therefore, 8x squared plus 10x minus 7 is equal to 2x minus 1, 4x plus 7. Nice. Let's do the same division over here. However, what we need to identify with synthetic is that we need to identify the 0. Right? So the 0 here is whatever the value of x is. Do you remember? That gives us a value of 0 for the expression. So so that's a half in this case. Twice a half minus 1 gives us 0. So a half goes in here. My coefficients of x squared, x, and x to the naught go in here. I have another line here, and then we can get going. 8 drops down here. 8 times a half is 4. 4 drops in there. 10 and 4 is 14. 14 times a half is 7. As expected, my remainder is 0. Now, how do we interpret this? I've got an 8 and a 14. Now, I've divided a quadratic by a linear, so this is a linear expression. This will be 8x, and this will be x to the naught, and this is my remainder. So what this says to me is that 8x squared plus 10x minus 7 is equal to, well, this half says not 2x minus 1, it says x minus a half to me. Right, that's what it reads, and 8 and 14 read 8x plus 14. Now this looks a little bit ugly, doesn't it? So what we're going to do, this factor here, we can take a 2 out of that, and so therefore we can write this as, I can take a 2 out of that, 2 twice x minus a half, 4x plus 7, and that's going to run that, we can distribute that 2 through the first factor here, so I'll get 2x minus 1, which is what we started with up here. So see how it doesn't quite work so nicely or so neatly for non-monic linear divisors. 4x plus 7 in there. 2x minus 1, 4x plus 7. We got there in the end. So we just need to remember that that's when we're dividing by a non-monic, then we're going to have, firstly, we're going to have a fraction in here, makes it slightly messier through here, and then we're going to have to pull out that common factor, and we're going to find that that common factor, in this case 2, is going to appear in one of our factors. So in this example, the long division hasn't really lost out by much. Let's have a look at another one. Okay, use synthetic division to find the quotient and remainder when dividing this polynomial by 3x plus 1. We've just done an example. I'd encourage you now to pause and do this example, and then come back and compare against mine. Okay, so my 0 needs to be identified, and my 0 here is negative 1/3. So that's going to feature just here. And I'm going to run off with my x cubed, my x squared, my x, and my x to the naught. 4 terms for a cubic, looks good. Okay, my 6 repeats down here, and now off I go. 6 times negative 1/3 is negative 2. Add those two together, I get negative 9 times negative 1/3 is 3. I add to get negative 12 times negative a third gets me 4. I add to get 5. So here I have a cubic divided by a linear. I've got a quadratic with a remainder here. So I've got a quadratic, x squared, x to the 1, x to the 0 there. So now my factors are going to look like this. So I've got my function of x is equal to x plus a third by 6x squared minus 9x minus 12 with a plus 5 on the end. Okay, I can take out, there we go. See, I've got a common factor of 3 in here. So that is always, that's going to be a feature. Whatever my, so if I divide by ax plus 1, ax plus b, then I'm going to have a as a common factor in one of my factors once I've done, once I've completed synthetic division. So I will take the 3 out of here, and I will run it through, I'll distribute it through the first factor. So I'll have 3x plus 1. See what I've done? I've taken a 3 out of the second factor, and so now I've just got a 2x squared minus 3x minus 4 in here, plus 5. All right, next example, we've got a polynomial and we're dividing by x plus 2. Right, our 0 here is equal to negative 2. So negative 2 is in this slot. Right, I'm dividing x cubed plus 3x squared, so x cubed, 3x squared, minus a minus 5. 4 terms, 1, 2, 3, 4. All my signs are in place, and I've got this unknown coefficient in here. So I've got to have some information about the remainder, and there it is, 3. So let's run this out and see what we got. 1 goes in place here. If you feel confident, move ahead, pause the video, jump ahead, find out what this value of a has got to be, and then come back and check. 1 times negative 2 goes into this slot here, negative 2. I add 3 minus 2 is 1. 1 times negative 2 is negative 2. I add minus a minus 2. Minus a minus 2 times negative 2 gives me 2a plus 4. So I end up with negative 5 plus 2a plus 4, which of course simplifies to 2a minus 1. So there's my remainder. There's my remainder there, and I know it's got to equal 3. So I simply need to solve the equation in A, that therefore 2a minus 1 has to equal 3, because that's in my remainder slot. Right, I've got an x cubed divided by an x, so I've got x squared, x to the 1, x to the 0, and my remainder. So remainder is 2a minus 1 equal to 3. Therefore, 2a equals 4, or a is equal to 2. And our final example, this one's a little different again. So let's just work through this one and see what the see what the strategy is. Find the remainder when this polynomial here is power of 2019. So we're hardly going to run off a synthetic division here with 1,000 noughts lined up. The other difference here is that we're dividing by a non-linear. So this would ordinarily result in, if we're dividing by a non-linear, we would use long division. But again, I don't think we're going to trouble ourselves with long division here. Again, we've got a better method. So dividing by x squared minus 1. Okay, well, let's reset. Let's have a look at my function of x. So remember, okay, go back to what the polynomial breaks down to when we divide by. Now, when we divided by a linear, we had a remainder that was a constant. So we're going to have here, we're going to have x squared minus 1 is our divisor. We're going to have some polynomial quotient, and then we're going to have a remainder that, in this case, because we're dividing by a quadratic, our remainder Well, it could be a constant, but it could be a linear. So remember, we can, if we're dividing by a power 2, then we can have a power 1 or a power 0 remainder. If we're dividing by a linear, we have to have a constant remainder. So our remainder here is ax plus b. So we can have a remainder in terms of x as a function of x. So what we're going to do is we're going to use our zeroed result from our remainder theorem, and we're going to put it to use here. So there's two values of x here that will just leave me with my remainder of ax plus b, and that's for 1 and for x equals -1. So when x equals 1, we get 0 in here, and we get a plus b over here. So we're just left with a plus b, but by substituting 1 in to my function, I can determine what my remainder is. So 3 times 1 to the power of 2019, so I've just end up with 3, plus 5 times 1 to the power of 1019 is just 5, minus 7 times 1 plus 4. So 8 minus 7 is 1, plus 4 is 5. So out of that, I get that a plus b is equal to 5. Let's do the same with -1. -1 to a negative power, to an odd power, will give me a -1 result. So I've got 0 here, obviously, plus, now I've got x in here, so I get -a plus b. Now, all right, so into -1 to the power of 2019 is -1 times 3, gives me -3. Another odd power here, so that's -5. Subtract 7 times -1, so that'll be +7 plus 4. So I'm on -8, plus 7 is -1, plus 4 is 3. So I end up with -a plus b is equal to 3. So here I have equation 1 and equation 2. I then, looks like I will use elimination here. I've got two equations in two unknowns, so I use simultaneous equations. Adding the two equations together, my a's disappear. I end up with 2b equals 5 plus 3 is 8. So b is equal to 4, and a must be equal to 1. So with that information, my remainder, and that's really what I'm after, find the remainder. Therefore, remainder is ax plus b, so it's just x plus 4. Okay, let's do exercise, where are we up to? Exercise 3K from the textbook. Okay, cheers.